Okay, so I would like to go over a algebra concept called the greatest common factor. And before I really go further, I want to emphasize that this is for groups, not necessarily for specific numbers. And so this is actually a requested video for eh, seems to be a problem that seems to be going around. So up on the board, I have some different problems for us, and they're just different things I just wrote. So the first one in this case is x times y plus 6 times x. And so we're asked to find what is the greatest common factor of this first thing here. So what they're really asking for is to look at each individual term that is either added or subtracted to each other and really ask what is the largest thing that they have in common that I can pull out from it. So in this case, we have an xy and a 6x. Now, what in either term can I pull out that I could easily multiply back in that would work out? So what do they have in common? Well, they don't. If you notice, this one has an x and a y. This other one, the second one, only has an x but no y, and there's a 6 here in front. Um, we're going to be limited by the by one of these terms. In this case, it's going to be the second one, so they both have x in common. So the greatest common factor in this case, the GCF in this case, is equal to, and it's going to be uh, x technically, and depending upon what your teacher or professor wants, they might want, what does this look like when you pull this thing out? Well, maybe it will look like, let's just say it will equal x times, in this case, y plus 6, because we're pulling out what they have in common. And again, if we were to multiply this x back into it, we should get this original equation, which we do. So the second one, we're asked what's defined, what's the greatest common factor here. So what do x squared, z, and y have in common? And this can be a bit tricky for everyone, but they have absolutely nothing in common. They are different variables. They could be anything. They do not have anything in common. So therefore, this is inconclusive. Your teacher might want you to say that in a different way, but essentially it's nothing, right? So going on from there, let's try, let me erase this guy, all these older guys here. There we go. There we go. So let's look at this third one here. And so the third one is kind of a monster. So we have x times y, xy minus y squared times x squared plus x to the 16th power times y squared. So we're asked to find what can we pull out from this. So if you notice, there's an xy in all three of these terms. So we know that it's going to be something xy, but we need to figure out to what powers they are, right? Well, we can only pull out one, right? Because this is to the first power. This is the first power. It's not stated, but that's what it is. We can only pull out one from each, right? If this were a y to the 2 or x to the 2, that would be a different thing, but we can only pull out that. Now that we pulled out that, what does the rest of the equation look like when we've taken it out? So this would be simply equal to 1 minus, if we take away 1y, and then 1x, it will be that. This one will be simply x to the 15th power because we took away 1. And this will be straight up y to the first because we took away 1y. So this will be your guy. Okay, so the next page here. We are asked the same thing for this fourth one. So 6x squared plus 12x to the fourth minus 36x. What can we pull out from all of these that are similar in each term? And automatically you're seeing an x, and that is very true. So it's going to be something x, but we also notice that there's numbers multiplied by all of these. So we have 6, 12, and negative 36. So what do all of these numbers have in common? What's the largest number that they have in common? It turns out that it's 6, right? So it's going to be 6, right? And I'm actually going to erase this real quick and write this down here. So this is going to come down here. So this is going to be a 6x, and then we write down what we have pulled out, what is left, I should say. So this is going to be an x plus 2x to the 3 minus 6, right? And if you factor this in, you should get your original equation. So 6x times x, 6x squared, 6x times 2x cubed, 6 times 2 is 12. X, which is to the 1, times x to the third. Whenever you multiply variables together, or whatever numbers or whatever has the same base, and multiply and you add the exponents together, as long as they're the same base, so they're both x's, therefore 1 plus 3 is equal to 4. So last one, which is 6x to the 1 minus 6, so you're going to get a negative 6 times 6, which is negative 36 times x, negative 36x. Okay, and so this last one here, it's going to be pretty interesting. So let me erase this guy. I'm going to just erase this whole thing. Okay. So this last one here, we have 12 divided by an n to the raised to the fourth power minus 60 times m times n divided by n to the sixth plus 24 over n squared. So now we're starting to deal with fractions and variables in the denominator and all that good stuff. So let's ask ourselves, we're going to do the same thing. What is common on the top, and then what is common on the bottom, and we'll pull out both, if that makes sense. So in this case, let's go down here again. So what is common on the top, right? We're going to have a top, we're going to have a bottom, and it's going to be multiplied by something. So on the top, we have 12, we have 60, we have 24. Well, I know 6 can go into 12, 60, and 24. So let's just do 6 on the top. Okay. And then let's just do the tops here. So, and I also know, let's actually do the bottom. So n to the raised to the fourth power, n to the sixth, and n to the second power. At most, I'm allowed to pull out an n to the second power because I can't pull out more from this. So it's going to be 6 over n raised to the second power. This is going to be, now what are we left with? We're left with 2 times n to the second minus, this is going to be a 10 m times n divided by n to the fourth plus 4. 4 or 4 over 1, right? Because we don't have any more of the n squareds. So this is what they mean when they say find the greatest common factor for groups. So depending upon your professor or teacher, they might say that this is the greatest common factor right here because that is what they all have in common. But then again, they might be asking for this whole equation. You never know. You really have to understand what your professor is asking for. So anyways, that is the greatest common factor for groups.